students and viewers. My name is CLASS-ABDULAZEEZ. I am here to present a lecture on set and number systems. And in this video lecture, we are going to look at the relationships between sets. So let's go. In an earlier video, we have defined what a set is. We said that a set is a well-defined collection of objects. These objects are somehow related, either in the way they function or the way they appear. We have also given the set notation. A set is always denoted by a capital letter, while its elements are denoted in lower cases. For example, we say let A be a set, we write it like this. Say an element A of A, so we write it like this, meaning A is an element of some set. And here is a set A. And we have also taught that an element being a member, we write A is in A, if A is an element of A, meaning A is contained in a set A. Or we write, if it is not a member, we say B is not an element of B, if you cannot find B inside the set B. So that is the relationship between a set and its members. In today's video lecture, we are going to look at subsets. Now, there are smaller sets inside some bigger sets. For example, one can think of the kingdom Animalia. These are containing some smaller sets. For example, the reptilia, they are there. The mammalians, there are smaller sets contained in a bigger set called kingdom Animalia. So let's define what a subset is. So subsets. A set A is called a subset of B subset of another set B if what? All the elements of A, all the elements of A are also in B. Meaning all the elements of A are in B. Then we say A is a subset of B. And we denote this by, so it is denoted by A is a subset of B. Meaning every element of A can be found in B. Now, to exemplify this concept, so we have an example. So let A equals to a set containing 1, 2, and 3. And then B equals to a set containing 1, 2, 3, 4, 5. See, all the elements of A can be found in B. 1 is in A, 1 is in B, 2 in B, 3 in B. And therefore we said A is a subset of B because all the elements of A are in B. Take note, if A is not equal to B, meaning B contains more elements than A, we write the containment as, we say A is a subset of B, meaning A is a proper subset of B. So, proper subset. So if A is a subset of B, A is a subset of B, and B contains more elements than A, contains more elements than A, we write A is a proper subset of B. We write something like this and pronounce it. And then pronounce it. And pronounce A is a proper subset of B. Meaning all the elements of A are also in B. And there are other extra elements in B than A. So we write this subset. Notice that some mathematicians or authors do write A is a proper subset of B, like this, while others just simply write A is a proper subset of B, like this. Meaning, if you write A is a subset of B, like this, it means there is possibility that all the elements of B can also be in A. Meaning, there is possibility that A can be equal to B. We are coming to it when we are defining equality of sets. So, equality of sets. Two sets, A and B, are equal if A is a subset of B and B is also a subset of A. A is contained in B and B is contained in A, and so we have equality. An example here we can cite as, see, let A be equals to ABC and B be equals to CAB. Clearly here, one can see that A is here, B is here, C is here. This A contains no more elements than B, and B contains no more elements than A, so we write A is equal to B. The two sets are equal, regardless of the arrangement of the elements in either A or B. We have to note that if I write A as ABC, I can also write as CAB. The order of the elements is immaterial here. So we write A is equal to B. So take. Here we have some remarks regarding subset. We all know that the empty set we have defined is a subset of every set. It's a subset of every set. Given any set, then the empty set is a subset of every set. So for all sets A, the empty belongs to A. 2. Every set is a subset of itself. Every set a subset of itself. That is, if A is a set, then A is also a subset of A. B is a set, then B is also a subset of B. 3. Now, if A is a subset of B and B is a subset of C, clearly, then A is directly a subset of C. Take an example here is you have if A is equal to A, B, C, and B equals to A, B, C, X, Y, and C equals to A, B, C, X, Y, Z, then here we say that A is a subset of B because every element of A is also in B. So we have A is a subset of B. So we can remove the possibility of equality, but even if you allow it, there will be no problem. So and also B is clearly contained in C. See, B, every element of B is also in C. And then, therefore what? You can conclude that A is also in C. Because A is directly contained in B and B is directly contained in C. So A is contained in the set C. Let A and B be two sets. A and B are two sets. Then the union of A and B denoted, it is written like this, denoted as A union B is the set which contains all the elements of A, and B put together. So the elements of A and B, when you collect them, all the elements of A and all the elements of B combined in a set, so you have the union of the two sets. Remember, in taking union, we don't take repetitions. So there are no repetitions. Mathematically, we write this as A union B is equals to X, set builder notation, such that X is in A or X is in B. So when you see an element in the union, it is either in the set A or it is in the set B. So an example here, can give an example. So let A equals to A, B, C, D, and B equals to A, X, Y, Z. So So A union B will be equal to A, B, C, D. So A, B, C, D, we have collected the elements of A. Let's collect the element of B. A is already written here, so we don't repeat. So this is X, Y, Z. So we add X, Y, and then Z. So this is the union of the two sets, A and B. Let A and B be two sets. The intersection of A and B, written as, so we write it as A intersection B. This symbol, the intersection, is the set containing the elements that are both in A and also in B. So A intersection B is the collection of elements that are in A and also in B. So mathematically we write A intersection B as the set containing X such that X is in A and X is in B. So those elements that are in A and also in B, we call them the intersection of the two sets A and B. An example here, let's use as an example, A is this, and then B is this. So here, A is equal to A, B, C, D, and B is equals to A, X, Y, Z, A, X, Y, Z. So what is A intersection B? A intersection B is equals to, how many elements are here and are also here? It's just A. So A is the common element here. So we write A. And that's a singleton set. A intersection B is a singleton set, contain only A as a member. So that is the intersection of two sets. We should also take note that as a remark, if A intersection B is equals to A, then A is a subset of B. And if A union B is equals to say A, then A is equals to B. So equality will happen if you take the union and it gives one of the two sets, clearly the two sets are equal. Now, if you take the intersection of any two sets and it gives one of the sets, then clearly the answer here, the one you got, is a subset of the other. Thank you for watching our video. Please do subscribe and like our videos for more.